Today what we're going to do is work on Chapter 11, Section 3, primarily working with perimeter and area of similar figures. Now, to do this, there are several different methods and several different ways of finding perimeter and area. I'm going to ask you to use proportions. It's a different way of setting up problems. It's a different way of thinking, and it's something that is stretching you outside your comfort zone. So it's a good thing. Then you'll have multiple ways of solving problems. And so when you do these, I'm going to ask you to please make sure that you set up proportions. Now, as we get started, here's the first example. It says compare the sides and perimeter and area. When we look at the sides of the figures, you're going to notice that these two figures are not congruent. They're similar. What that means is that they're the same shape. They're just different size. So you'll notice that A is smaller than B. So if we're looking at these sides, I tend to do the smaller figure over the larger figure. Now, you do not need to do that. That is just only what I do. You could do B over A, but the important thing is you need to remain consistent. So for example, I'm comparing A to B. It's A over B. So if I were to compare the perimeter, I would also compare A to B. So let's say they're squares. They're a little distorted, but let's say that they're squares. If they're squares, then to find the perimeter of A, what I would do is I would take 4 times one of the sides, and it'd be 4 times B, which is over the other side. So you're going to notice that if I reduce that, the proportion to each other is still the same as just comparing the sides. Now, when we do area, it's a little bit different. With area, remember, it's base times height. So if that's a square, and this is A is the base and A is the height, I get A squared. And if I look at B, it's B times B, so that's B squared. Okay, so notice that the perimeter and the side are in proportion to one another, but that the area is squared, and that's what's key in today's lesson. So let's take a look at this first example. Again, let's say they're squares, okay? So if I were going to compare the sides, I would have, here, I'll change the color to make it different, 3, which is the smaller figure, over 5, which is the larger figure. If I looked at the perimeter, okay, it'd be 3 times 4, because there's 4 sides, over 3 times 4, I'm sorry, 5 times 4. 5 times 4, because 5 is the side measure and there's 4 sides. So I get 12 over 20. And then if I wanted to reduce it, which of course I do, of course it's 3 over 5. Okay. And it just goes to show you that if I find the perimeter and I reduce it, it's the same as the sides. Okay, so that's really what it's showing you. To find the area, what I'm going to do is I'm going to take 3 squared, because again, it's base times height. And I'm going to take 5 squared. And so I end up with 9 over 25. And so you'll notice that the area is a little bit different. Now, one thing I'm going to really encourage you to do is while you are doing your practice today, make sure that you're checking your answers as you go. It's a very common mistake that students don't check their answers because they think it's easy and then they get it wrong. One of the things that they'll do is they'll take 3 squared and get 6 rather than 9. So just be careful and make sure that you're checking your answers as you go. Let's keep going. We're going to find the area of a larger polygon. And you'll notice that the smaller star has 3 meters and the larger polygon has 5 meters. And then you'll notice that the area of the smaller figure is 27 inches squared. Now that little caret into the square just means that it's that little 2 above the inches. So what you're going to do is, first of all, we're going to set up the sides. So I'm going to go like this, and I'm going to go 3, and I'm going to go 5. Now, because I am doing area, and I am comparing areas, I am going to square these. Okay, so anytime you compare a side length to area, I'm going to square the sides. And then I'm going to go equals. The area of the smaller figure is 27, and I don't know the area of the larger figure. So when, again, you are comparing the side length to the area of the figure, you need to make sure that this is squared and this is squared. You square the sides. Once you do that now, what we're going to do is we're going to go further and we're going to work with these proportions a little bit better. So 3 squared is 9, 5 squared is 25, and it's 27 over x. Now what I'm going to do is I'm going to do my cross products. So I'm going to come over here and I'm going to grab 9x equals 25 times 27. Notice that I'm not going right away and just multiplying. Again, I'm doing my cross products. I would rather you write 25 times 27 because what students will do is they'll put it wrong in the calculator, and I don't know if they grabbed the wrong number. I don't know if they multiplied wrong. Like, I don't know what they did wrong. So I really encourage you to write 25 times 27 and then go ahead and work it through. So x is going to give me then 75, and it's going to be inches squared. And that is the area of the larger figure. Key points on this problem, again, make sure you square the sides when you're comparing it with the area. The second thing, when you do cross products, write down 25 times 7 rather than going right into it. And then also remember that if your answer is area, you're going to put a square in the label. Let's go on and look at the next figure. This is find the area of the larger polygon. We just did that, so we're fine. Let's go on and let's take a look at this. Now, in this figure, they gave me the perimeter of the smaller arrow and then the perimeter of the larger arrow. They also gave me the area of this. And so what they want us to do here is they're going to want us to find the area of this arrow. So why don't we use this space right here to help us with it. Again, I'm going to set up my proportions. So you're going to notice that I got perimeter and perimeter. So I'm going to take the smaller perimeter, 27, over the larger perimeter. And I'm going to square these because, again, the perimeter and the side length were very similar to each other. And then what I'm going to do is I'm going to grab my area. I've got the area of the smaller arrow, which is 7.5 centimeters squared. I'm not going to put centimeters squared there, but I am going to put 7.5. So this is 7.5, and then I do not know the area of the larger figure. So now what I'm going to do is I'm going to take this and I'm going to clean it up a bit. 27 squared is 729. 36 squared is 1,296. And I still have 7.5 times the area. Now what I'm going to do is I'm going to take this and I'm going to do my cross products. So I'm going to take 729A equals 1,296 times 7.5. Again, I like to use parentheses rather than a dot for multiplication just because you can get it confused with more decimal points. I also don't like to use the variable x because it looks like a variable. So I'm going to did my cross products. I'm going to go ahead and work this through. So 729A equals 9,720. I'm going to divide by 729, and A ends up giving me 13 1/3 inches squared. Oops, centimeters squared. Okay, and if they ask you to round to the nearest hundredth, it would be 13.33 inches squared. So just be careful with the directions too, with how to round. So again, just like up above, if I'm comparing side length or perimeter to area, you're going to square that measure. Notice that I did my cross products. Notice how I showed my work using algebra, and then I found my answer. Again, there are multiple ways of finding these answers. However, this is another method that you could use when you're taking an ACT to check your answers. So it is a valuable method. All right, let's go down to this problem. You're going to notice that they gave us that this is 10 inches, but they do not give us the side length. They want us to actually find that side length, okay? And they gave us the area on the smaller figure and the area of the larger figure. So I'm going to go ahead and I'm going to set up proportions. I got the small length side. I do not know the side length of the larger figure, so I'm going to call that XY, and I'm going to square it, and I'm going to square this because, again, those are the side lengths, and I'm comparing it to the area. So the area of the smaller figure is 336. The area of the larger figure is 525. I'm going to go ahead and I'm going to clean this up a bit, and I'm going to go 100 over XY squared. That gives me 336 over 525. Again, all I did was take 10 squared. Now what I'm going to do is I'm going to do my cross products. Okay, so to do this, what I'm going to do is I'm going to take 336 and it's XY squared equals 525 times 100, 336 XY squared. And if that makes you uncomfortable to do XY squared, you could put another variable in. Just be careful that it's not a variable that's already used in the picture, so you could choose something like M, right? That equals 52500, so 52,500. Divide both sides by 336. So XY squared equals 156.25. And then the final step, we're going to square root both sides because that gets rid of the squared. And so I end up with XY equaling 12.5, and it would be inches. Okay, and it's bigger than the smaller figures, so that's a good thing. Again, when we do this, make sure that the sides or the perimeters are squared before you compare them to the area. You're going to do your cross products, and then you go ahead and run your algebra through. Don't forget to square root at the very end if you need to. All right, let's look at the last problem. A regular decagon has the perimeter of 170. Another regular decagon has side length of 34. The area of the first decagon is about 810 inches square. Find the area of the second decagon. So this is kind of a common problem that you would see on an ACT. And where it gets confusing is that there are several different shapes that they're talking about and lots of different measures. So my advice to you here is to kind of pick things out. You've got a regular decagon. It has the perimeter of 70. So I would write decagon 1. Okay, and because it's a decagon, I know that it has 10 sides. So just kind of FYI. Okay, I know it has the perimeter of 170. Now it talks about another decagon. So I'm going to color code that. It says another regular decagon has the side length of 34. So I'm going to go decagon number 2. Okay, again, it has 10 sides. All this really does is tell you that I've got a smaller decagon and I've got a larger decagon. So just kind of a heads up on that. The 10 doesn't really do that much for you right now. So it has the side length of 34. So side length equals 34. Okay. The area of the first decagon is 810 inches squared. So area is 810, and I'm going to put inches squared here because I know what the label is. And I can color code that again because this is the first decagon. And it asks us to find the area of the second decagon. So I'm going to change this, and area equals question mark. Okay, so I know that I need to find area, and they gave me the area of the first one. What causes a problem for us in this problem is you're going to notice they gave you the perimeter here, and they gave you the side length here. Okay, and so what we need to do on this is we either need to take the first decagon and do side length on that, or we need to take the side length on the second decagon and find the perimeter. In other words, what I could do on the first figure is to find the side length. I take 170, divide it by 10 because it's a decagon, and I get 17. Or if I wanted to, I could take the second decagon and I could go the perimeter is 34 times 10, and that gives me 340. It doesn't matter which one you choose. You do not need to do both. Okay, so what I'm going to do is I'm going to go ahead and I'm going to take my proportions, and I like to do side length because I got less numbers, or I should say smaller numbers. So I'm going to take the side length on the smaller figure, and I'm going to put it over the side length of the larger figure. And then I'm going to take the area of the smaller figure. Notice I'm going to put that in the numerator. And I'm going to try to find the area of the larger figure. Now, before I do cross products, again, what I need to do is I need to square those side lengths. Make sure that you do that. That's the number one problem students make. So then what I'm going to do is I'm going to grab my my proportions, and I'm going to take 17 squared, and I get 289 over 1,156. I've got 810, and I've got the area. Then what I'm going to do is I'm going to grab my cross products. I've got 289A equals 810 times 1,156. 289A equals 936,360. I'm going to divide by 289. So A ends up giving me 3,240, and it'll be inches squared. Inches squared because, remember, the smaller figure was in inches. Okay, that is it for today. Again, this section tends to be harder for students because at first when you look at it, it's really easy. I can number crunch. I could not use proportions, and I could still come up with the same answer. Again, it's looking at this from another perspective. So really important that you're setting up proportions and that you're squaring the numbers of the side length and the perimeter when I'm comparing it to area.